ReasonConf is brought to you by our gold sponsors, Ahrefs and Chain Street.
And on Discord as well. And yeah, I work for Imandra, which is where, if you're wondering what this banner was for, hopefully I'll give you a bit of information about that now. So, yeah, what is Imandra? Imandra is like it's a theorem prover and a reasoning engine. Yeah? Is that good? A bit more, cool. Cool. So it's a theorem prover and reasoning engine that we'd originally written in a camel, but obviously because reason is just a syntax for a camel, it now just works with reason code as well. And it's a tool for kind of like, thinking about your code and for formally verifying it. And if you don't know what formal verification is, I kind of like to think of it like this. So you can write your code, and then you can write tests about your code is one way of kind of verifying that it does what you think. And a type system is another way of verifying that your code does what you think. A theorem proof is kind of like a third angle on it. So yeah, after you've written tests and used a type system, you might want even stronger guarantees that your code does what you think it does. So a theorem prover lets you kind of write your own constraints. So a type system is kind of technically like proving properties of your code according to some convention that like the type systems originally come up with. Whereas like with a theorem prover, you can write your own sort of conventions. So it's a sort of like programmable type system that you can control fully. So it's probably not for every project, but like if you're working on some really like hardcore logic and you want to be 100% sure it does what you want, you might want to think about using something like this. And traditionally, theorem provers, you'd have to like write your proofs in a different language, like Coq or Agda or something like that. And it's a sort of, would be a model of your code, not necessarily like the actual code itself. So you'd write your code in one language, you'd sort of transcribe it in another language. What Imandra lets you do is just use a camel or reason for everything. So you write your code in that, and then you can also prove stuff about this exact same code, which is nice. So yeah, like one tweet I like is this tweet from Ken Beck. So he says, all the value that came out of TDD and writing tests is the fact that you've kind of like implemented it twice, and tests are like a form of double checking. Types are the same sort of idea. So you're in one frame of mind when you're writing your code, you're in another frame of mind when you're writing your types, another frame of mind when you're writing your tests, and then if you're formally verifying, it's like another view on it. So it helps you kind of eliminate more problems. So yeah, the reason we picked a camel is because everyone talks about how a camel and reason have like a sound type system compared to something like TypeScript. And that is actually what enables us to, let me try and wrap this. It's what enables us to like do rigorous mathematical proof on a subset of a camel to enable this to happen. So it just makes things a bit more accessible. So what does it actually look like in practice? We've got this kind of REPL, which also accepts reason syntax. And you can kind of type statements. So it adds this keyword verify, and then you can sort of, give it, the interface is a camel or reason code. And you can give it statements to say, like, for all values of x is equal to 3, which we wouldn't expect to be true. So it says, that's wrong. We can find an x where x isn't equal to 3. And it'll give us like a concrete example. So it gives you the value 4 to say, when x equals 4, x isn't equal to 3. So this is quite useful. Like it's counterexample driven. So every time it finds a problem, it'll give you like a really solid example that you can like work on, rather than some kind of abstract symbolic representation of what you're trying to do. So sorry, where's my window gone? But yeah, so you might think what's happening here is it's kind of when you pass in when you put the statement x equals 3, it's kind of running at runtime, it's passing loads of different values of x in, finding one that is where it doesn't hold. But it's actually just statically analyzing that expression. It's not running that expression at all. This is all done like statically, and nothing needs to run a bit before. You never have to run your code essentially. So it's different from something like quick check, which is actually executing your code. This is just pure like analysis of the code statically. But so as part of that analysis process, we kind of load the whole code into Imandra, and it sort of is able to like manipulate it, help you reason about it. And something that we're then able to do, which is what I want to talk about today, we've been trying to kind of like bring this sort of stuff to the front end, seeing as Reason is quite sort of front end focused. And so what you can do is, if you're working on, say, a React project, you can write the like core. If you're using something like reducers in React, you can write the kind of pure logical core of your React component in this analyzable way, and then wrap it up in a component. And that enables us to do some sort of quite interesting stuff. So I'll give you a quick example. So we've got a kind of model of like the to-do MVC, like core logic here. So this is kind of the like middle logic of the app. So here's all the various actions you can do. So you can like add a new to-do, hover over it, edit it. And then once you've got that logic written, we can wire it into like an actual Reason component. So where's the actual reducer part? Here we go. So this reducer in the component is just delegating down to that logic module we've written, and doing a bit of mapping from the actual front end into the logic. And so I'll just show you what that looks like here. So here's the to-do MVC app that we've got the logic for. I won't say let, I'll say buying milk. And yeah, it works. But because we've got the code of the component in this sort of analyzable way, we can query it. So in the same way that Imandra found us an example of where x wasn't equal to 3, we can ask it to find us other examples. So we can say, like, find us an example of the state of our logic where we've got 5 to-dos. So it just generates, when Imandra's returned the sort of state, we've hooked up the component to render it. So here it's just generated a state where we have 5 to-dos. It's kind of a bit lazy, so it won't put text in or anything like that. We can add other constraints to make things a bit more interesting. So I've got this with to-do text, which essentially just says, like, give me a to-do with some predefined text in, and I can edit this on the fly, and it will just dynamically generate states for our UI just from analyzing your code. So yeah, a bit more interesting one. Some of them are ticked off here. And finally, we can kind of test the like reducer logic's update function by calling our actual actions on it to sort of, yeah. This is finding us an instance where these actions have been run on the state of the UI previously. So we've edited the to-do, and then we've added it, and it's solved the constraints and found an example for us there. So yeah, it enables us to do kind of like analysis of UI components. Is there anything else I want to say? So if I've sort of piqued your interest at all, and you are interested in learning more about this, there's some kind of, on our docs site, there's docs.imandra.ai, and we kind of go through things in a bit more information, like introduce things a bit more slowly, and explain how things work. We've got worked examples in Camel and Reason. So we've got one where we're kind of proving properties about tic-tac-toe, the game. We've got one about finding bugs in sort of different pieces of logic. And yeah, some of them work in Reason code now. And if you want to play around with the code at all, you can hit try this and then sort of edit the examples on the fly. So yeah, if you're interested in learning more, check out docs.imandra.ai. I think that's everything. Let me just check on here. Yeah. So check out the docs if that sounded interesting to you. But thanks very much.